Guys, welcome back to my YouTube math channel. So today I want to talk about some shortcut methods that work for functions that look of the form ax plus b. So it may not work for everything. For the other functions, we have to go back and look at the rules, or we have to use the substitution method. In fact, the four types that I'm going to show you today in this video and in the other video can also be actually evaluated using the substitution method. But guys, in order to save some time, you can also remember some techniques and some tricks, or you can think of these as shortcuts. And when you are trying to solve these examples for your homeworks or other places, you can just simply use them directly. So what I'm going to do is I'm going to write them. I'm going to write these four shortcuts, or you can think of these also as rules. And then I will also illustrate these by some examples as well. It is not too complicated, but I just want to share this with you so that you also have these rules and these shortcuts with you, and you can use them when needed. Okay, so guys, the first one, keep in mind, you will see that all of these four types that I'm going to talk about will involve ax plus b, which you can think of more like a linear function. You remember y equals to mx plus b, which is a linear function, so it is similar to that. So guys, the first one is if you have of the form, and we are trying to integrate, still we are doing the indefinite integrals of something of the form ax plus b raised to the power n, and with respect to dx. So guys, the shortcut for doing this is you kind of treat, so that's how I like to remember this. We kind of treat it like a x to the power n. So if it was x to the power n, we would use the power rule on it, and that power rule is simply that you just rewrite the ax plus b, the variable, whatever this is, and then you raise it to the power. We know we raise it to the power n plus 1, right? We do n plus 1, and we do the same thing in the denominator, n plus 1. Of course, there's a plus c, constant of integration. And then there's one extra piece that shows up when we are actually working with functions of the type ax plus b, and that is every time you try to evaluate the integral of a function of this form, there is this a that comes right here in the denominator. So that will happen every time you are trying to integrate a function of this form. So guys, this is how I like to remember it. It is something similar to using a power rule, and then I'm dividing by the a. And you can think of that a also as the derivative of the inner, which is the derivative of the piece inside the parentheses. Like if we take the derivative of this, it would just simply be a, because the derivative of b as a constant is just 0. So guys, I also kind of relate it somewhat to the chain rule in the derivatives. That's how I like to remember it. So you remember, for the chain rule in derivatives, you take the derivative of the function, whether you have to use the power rule or some other rule depending on what the function is, and then you multiply by the derivative of the inner piece, right? Now here we are doing the antiderivatives, or the integrals. So when you are doing the integrals, we know integrals are the reverse process of derivatives. So instead of multiplying by the derivative of the inner, we are basically dividing by the derivative of inner. So that's how I like to remember it. So guys, it's up to you how you want to remember it. I'm just sharing my technique of remembering this shortcut. Okay, so whenever you have something like this, again, you can do it. We can simplify this or evaluate this using the substitution method. We have already covered a lot of examples on the substitution method, and I'm hoping and expecting that you already know how to use the substitution method, or you can just simply use the shortcut. Now guys, I'm not going to show you or derive this integral using the substitution method. I would let you guys do that on your own, but what I'm going to show you is an actual example, and we will apply we'll just use the shortcut formula, and then we'll also use the substitution, and we'll convince ourselves that both actually give us the same results. That also convinces us that this actually is a valid formula or a valid shortcut. Okay, so I'm going to show you one example on this one. So let us say we want to evaluate the integral of course it has to be of the form ax plus b, a linear function. Let us say I have 3x minus 2 raised to the power 3, and that's what we want to evaluate. So guys, just using the shortcut method, it would simply be the 3x minus 2 raised to the power n plus 1. 3 plus 1 is 4, divided by 4 plus c, and of course we have to multiply the denominator, or divide this by the derivative of the inner, or just the a if you just want to compare these. So a obviously here is 3, and 3 in fact is also the derivative of that inner function, the function inside the parentheses. So it's going to be times 3 here, and if we simplify this, 4 times 3 is going to be 12. So guys, it took us like what, 5 seconds or 10 seconds to come up with the integral of this function using the shortcut method. I mean, you have to remember this, but there's nothing really complicated about this. It is just an extension of the power rule for integrals, okay? So if you have this in the formula sheet and you're allowed to use the formula sheet, that's fine. Then you can just look at the formula sheet and use it right away. But if it is not on your formula sheet, first of all, or you're not allowed to use a formula sheet on the quizzes or tests, then guys, one should try to remember this. And I already shared with you like the technique to remember this one. So guys, this is the integral using the shortcut method. Now let us also use the substitution method that we already learned and see if we get the same answer. So using the substitution method on this, we already know that there are 3 steps to a substitution process. First one is to start with the right substitution. Here we don't have too many choices, so we've got to start with saying that let u be whatever is inside the parentheses, 3x minus 2. That is the first piece. Then the second step is to find the derivative. So du over dx is, so let me make sure that this actually looks like a u, and the derivative here is going to be just simply 3, right? And then we have to solve from this equation, we have to solve for dx. Dx obviously will be du over 3. I like to circle this, and I also like to circle the first one because these are the 2 things that we have to kind of bring back and substitute for in the last step. So in the last step, it's going to become integral, and then 3x minus 2 will be replaced by u cubes, right? And then dx obviously will be replaced by du over 3. Okay, so we transform this into something simpler. And from here, what we can do is there's a 3 in the denominator, so it's like multiplying by 1/3, so we can already take it outside the integral sign. And I just have integral of u cubes du. We already know how to integrate this just directly using the power rule. Using the power rule, this would be u to the power 4 divided by 4. We know this is multiplied, so it is simply u to the power 4 divided by 12 plus c. But what is u? Guys, u is, now after this step, we have to go back to the step number 1, and we have to replace that u with whatever we have started with. So it is 3x minus 2 raised to the power 4 over 12 plus c. Guys, please check this and then see this exactly looks like what we have from the shortcut method. And guys, that's what I have been trying to say, that we can also use the substitution method directly on this expression, and we'll get the integral to be the right hand side. So it's up to you. If in case we forget these shortcuts or these tricks or techniques, then we have to rely on the actual method, and in this case that actual method is the method of substitution. It has 3 steps. Of course, there's other things that one has to do while we try to use the substitution method, which comes with practice, and then you will be able to get the right answer for this. Okay, so guys, this is number 1. I also want to show you 3 more which involve ax plus b, so that you have you got to see all these different types that will help you when you are trying to actually solve these integrals on your own. Okay, so guys, I will see you in the next video with the other 3, and I will also illustrate them with 3 examples as well. Okay, it's going to be pretty easy, but we just have to see it one time. Okay, I will see you in the next video.